Fine. I'm going to try to actually I will attempt to talk about the convergence and integration of AI and 6G because I'm going to try to squeeze as much information about this within 35 minutes. That's not easy, and by no means I'm going to claim that whatever you hear today is the whole story. In a nutshell, I would like us to start from trying to understand the problem, trying to answer what we mean by saying the convergence and integration of AI and 6G. Start with defining a few fundamentals like what's intelligence, cognition, and something that people usually neglect, that there is a distinction between AI and ML. Then the second part of the presentation is understanding why 6G is different. Actually, it's radically different from previous generations of telecommunications, and stress on the fact that we envision it as human-centric. So the first two parts, understanding the problem and 6G comparison against the previous generations, is going to be a little bit more high level. Hopefully, as we reach to the third section of it, we will be able to better understand what we mean by the convergence and integration and focus on what we do in the Reason project, what is our view towards this convergence. And before I proceed, hopefully we will talk more things than just what we mean by AI orchestration. If we have the time, we will talk about three important architectural pillars that we have in the Reason project, which is a UK VC funded project, by the way. And if we have the time, we will dig into monitoring. Otherwise, we might need perhaps during the discussion time return into that. So these are all technical parts. The last thing is that the Reason project involves, besides me as an academic, of course, Dimitar Simeonidou, who is the co-director of BDFI, and other fellow academics who are members of BDFI, Yulei Wu, who is here with us today, Rashid Hussein, and I hope I'm not forgetting anyone. Then today we've got with us Dr. Shadi Mohseni, who has recently joined BDFI. So the Reason project is closely related to the things that we do in BDFI. So let's start with understanding the problem. What do we mean by saying intelligence? We're not talking yet about artificial intelligence. So it's the ability to acquire and apply knowledge so that you solve problems. Having that said, sometimes it's very difficult to understand if there is a difference between the concept of intelligence and cognition. They almost identify. Cognition involves all the processes and activities which are related to acquiring and processing information. And some examples that you can see on this slide span from perception, attention, and memory, and problem solving up to human language and understanding human-like information. So what is left for intelligence which is not part of cognition? Well, things like emotional intelligence, creativity, the musical intelligence, which is the ability to compose music, physical intelligence. These are not part of cognition. Physical intelligence means, for instance, that it's one thing to know how to compose music, but training your muscles, your hands, how to handle an instrument is a different story. Or how plants and trees pump up water. It's not a trivial thing. So this is a sort of intelligence. And definitely self-awareness, which goes beyond cognition. Okay, and now we're moving to the realm of artificial intelligence. It's exactly what we defined before, but this time computerized or softwareized. So all the computer and software systems that we build in order to perform tasks that otherwise would require human intelligence. So what is the exact definition of machine learning? Within the concept of artificial intelligence, it involves all these optimization models which take optimized decisions or try to optimize predictions based on data. Having that said, you can have AI solutions which do not necessarily fall within the realm of machine learning. If you're trying to mimic, for instance, human behavior, this is not part necessarily of machine learning because humans can make mistakes. Humans are prone to errors. So it's not easy actually to find examples which lie outside of machine learning. The most obvious one is rule-based systems. So systems which not use models that learn from data, but they learn from human experience. So human experts sit down together and they create an algorithm that has a list of rules to use. And then there are things which lie in the borderline between machine learning and everything else, because they may or may not use optimization models, things like symbolic reasoning based on understanding symbols, and expert systems which may use machine learning or may directly use rules. Okay. And artificial cognition comes as a result of using AI, and more specifically, what we care more, in our case, for the convergence of AI and 6G, is the use of machine learning models for artificial cognition. And that's the main thing we use in telecommunications. Okay, having that said, let's try to make a first attempt to understand what's the convergence and integration of AI and 6G, at least from the point of view of our research here. There are three important things. The first one is native intelligence. Unlike the past, that we had a given telecommunications architecture and we tried to add over the top of it to patch, if you want, AI models over it, this time we try to embed in the very design of the telecom architecture AI models. And this is something that has a lot of advantages. Actually, it doesn't bear the disadvantages of not thinking about AI when designing the architecture. One of the things is, for instance, monitoring. Okay, so intrinsic intelligence, which is an enabler for full automation. There is a concept called zero-touch network and service management. This pretty much means, in one sentence, the ability of the network itself to configure itself, to monitor itself, if it finds out that it needs to heal something, to heal itself, and to continuously optimize itself. All right. And by the way, you can also use this concept to even further increase the embedment of AI in the architecture. And then both of them, they are an enabler for what we call human centrism. Give a very short definition. By saying that the network will be human-centric, we mean that the services that will be given to humans will adapt to humans and not the other way around. And I'm going to try to explain later on this with an example. Okay, so how does 6G compare with against the previous generations? Well, in the previous generations, we used to have a pool of rich resources. So this one shows a typical server farm with a human administrator in the middle. The human administrator tries to allocate resources, decide which are the appropriate policies, or if there are policies and static rules given to the administrator. With the help of some scripts, the administrator tries to do the best possible allocation and handling of resources. But in the 6G world, we expect that things will be super complicated and characterized by unprecedented operational agility, which comes as a result of moving things from purpose-specific hardware to programmable and softwareized hardware. That increases agility, but at the same time, it makes things more complex because you need to assign dynamically resources, the given resources, to softwareized components. Things are not static as they used to be. And then other technological breakthroughs besides programmability and softwareization include the ubiquitous connectivity that we now have available, like Starlink, that's one example. Or here in BDFI, we've got a solution that we call the nomadic node, which is pretty much a whole network in a box that you can move, place it somewhere, and then out of nowhere have a 5G or in the future a 6G network. So things are very complex. And now going into the services, the requirements will be super stringent. Just a few examples over there. You will have to give the illusion to your services using the network that there is an infinite amount of capacity on the network, although this is not true. Okay, the network shares its resources to all the services. You might need to sometimes deal with very hard constraints on latency. You have to have ultra high reliability. Global scalability means that if I enjoy a service here in the UK, if I suddenly teleport somewhere else, let's say Australia, which is far away, then I should enjoy exactly the same service, giving me the illusion that I'm over here. And okay, massive machine communication. You could say that these first examples, they also exist in previous generations, but this time they're even more stringent. Some new things are customization, or if you want, individualization of services. So this is what we mean by human centrism, by the way, that it's humans that define what this service should be, and not services that they are designed in a way to cover a specific group of users. And there are more abstract things that come as requirements, like how do you guarantee sustainability? How do you make your services human-centric? To achieve all that, you have to get rid of the human, because a human administrator cannot scale anymore. They cannot take decisions as fast as needed. They cannot take super complex decisions within given time constraints. We believe that it should be AI automating the process. And that comes along with a new networking paradigm, an intelligent cognitive-based paradigm, where you're given high-level tasks, high-level policies, not a very specific technical description of what you need as a service. And that has to be understood from AI, then deliver the service. Then the AI models handling the service should be learning from data on how to optimize the service, real-time dynamics, and of course, provide a customized service at the end of the day. So let's try to focus on an example of a human-centric service. We're all familiar with social networks, but what if me in the future want to say, okay, I want my own type of social network where I don't share content with anyone. I just want the social networks to work as a search machine so that the people that I define as friends can have access to my content. Then, based on the rules that I create, content can move from my personal device to their device, or I can trust only a specific set of my friends to host my content on behalf of me, cache it, and then distribute it. And imagine that I may want to do this and then teleport to Antarctica in the future or to Australia and still want to have global reachability on my content without having the content hosted in the cloud. It's always on my device because that's the way I want it. Okay, so we need to make the orchestration of resources human-centric. That means that we need to involve AI into the process. We need to understand the individualized user preferences. Once we understand it, convert that to network requirements, and then provide the necessary agility, which means the ability to adapt rapidly to changes, like me moving somewhere else, or me changing the rules, saying, okay, I used to trust you for caching and sharing my content on my behalf. I don't do that anymore. Or I trust you only for a specific type of content, and so forth. Then machine learning should also identify traffic patterns and, if needed, reconfigure the service so that it keeps running, and so forth. And of course, deal with socio-technical aspects, which means translating what we said earlier, high-level policies into management and orchestration network actions. Now, this comes from a very nice slide from our co-director, Dimitar Simeonidou. There is a concept of KVIs, key value indicators, which need, with the help of AI, to be understood and, based on the context, translated to key performance indicators, like latency, for instance. One example is, what if I say I want my service to be sustainable? What does it exactly mean? Well, with the help of AI, we may translate that to a series of KPIs related to energy efficiency, like consumption, or consumption over the number of devices used. What if you also want to have your service being adaptable and also guarantee inclusion and equity between all the users of my service? These are very abstract concepts. AI has to translate to a series of KPIs, from low latency for everyone, or for some people it might be more critical if it's a health-related service, for instance. Coverage, cover as much as possible. That doesn't mean cover everyone, because there might be some users that are in need of the service more than others. Low latency and so forth. And just a few more examples. So you start from high-level description, and you have to translate things to concrete KPIs at the end of the day. That's the high-level role of AI in the new orchestration process. Which brings us to the third and last leg of this presentation, the more technical one, where I'm going to try to explain our high-level vision in the Reason project about the convergence and integration of AI into 6G. So what used to be the reality in the past was that you had just some cloud resources, and you would try to interconnect these resources so that you provide the necessary infrastructure for your service. Then recently, in the past, while conducting research in 5G, we tried to integrate intelligence and automation, so it wouldn't be a human administrator anymore trying to connect the resources, to orchestrate the resources. It would be an intelligent algorithm. But because the telecom architecture was not ready for it, it only had functions for telecommunications. That meant that you would have to patch intelligence over the existing architecture. And here is a small example. I'd like to go through that very, very quickly. So in this slide, without getting into many details, this slide outlines an effort that we did in our lab in a project called ZeroD, along with Samsung. What we tried to do was to guarantee that if a user moves from one cell to another and they're enjoying an edge service, then I didn't know that happened, that they would seamlessly continue enjoying the service without any downtime. To do that, you would have to proactively, for instance, move the service, which means that one of the many things you would need to do was to predict that the user would move and so forth. So you had on your own to decide what type of machine learning models you need, not the network, not the integrated intelligence of the network, but you, the designers. Then besides this, how to orchestrate machine learning itself. You would have to answer to questions like, do I put it on the edge? Do I replicate the models in every edge point? Do I place them in the core of the network? Do I stay only within this domain, or do I engage another domain as well for running the service in case I don't have enough information? Is data going to be distributed? Are the models distributed? Are they federated? Then how do you deal with the necessary monitoring of data you need for inference reasons and for training purposes to always monitor your service? If the architecture is not designed to provide you that, then you have to manually work as part of the solution. Okay, I said that about intra or cross domain. In general, you would have to worry about the whole AI ML lifecycle and engage into traditional MLOps. Well, going back to here, we were at the point that we were talking about how we tried as a first step to patch intelligence. What we want to do now, our vision, is to integrate monitoring and analytics, then also monitoring and analytics functions in the very design of the architecture, of the 6G architecture. Also, make the architecture have the right functions that will accommodate hosting AI. That means that the story is not anymore about orchestrating resources, but it's beyond just that. It's about orchestrating AI models themselves. This is what we call by AI orchestration. Fully automating the architecture, what we said earlier about this ZSM model, about zero-touch networks. And a series of other things like creating an architecture which is going to be friendly to create digital twins of the architecture so that you can make your own predictions somewhere else about the network. Is it, for instance, getting under an attack? Will it fail in the future if you increase demand? So in the very design of the architecture, we try to make it friendly. And besides these obvious things that you need for AI, this is the right time to include more than just one access technology. In this figure, you see other technologies from Wi-Fi up to Li-Fi, for instance. And that should work not only for one domain, but across multiple domains. Overall, you will need to have what we call multi-domain cognitive network architecture. That is the high-level vision. Let's now try to gradually get into the details. So what is the scope of the convergence and integration of AI and 6G, at least from the reason perspective? We already said that we are dealing with a radically different environment in 6G, unprecedented complexity, agility, flexibility, dealing with abstract or dynamic requirements and the very stringent ones. If you want to deal with that, this implies that you need to take optimal and very, very complex decisions beyond just management and orchestration of resources. You need to make your services sustainable, and you need to understand and deliver high-level tasks and goals. And the only way to do that is by having native intelligence and automation within the very architecture in 6G. And that's the core vision. Optimal and complex decisions based on native intelligence and automation. But how does one achieve this? Well, first off, the most important thing, it's not the only one, is AI model orchestration. It means a lot of things, but two things to have in mind is that from one side, you've got the network requirements for your services. And on the other hand, you have AI requirements about the quality of the AI models themselves. It's one thing to try to optimize your AI models, like having super accurate decisions. But what if they take decisions very slowly compared to your requirements? Then you start violating your network requirements. So at the end of the day, you need to orchestrate your resources and your AI models in a way that they are accurate enough, fast enough, and cost-effective enough. Because your resources are limited. You don't have access to all the resources needed always. So this is one enabler. In order to have AI orchestration, you need to have available monitoring and analytics. This means access to raw data from the network and the services, or more complex data and statistics. This also means that you need to have all the necessary functionality for fine-grained monitoring data, either in time or in space. Will it be every millisecond? Will it be below the limit of a millisecond? Will it be every 100 milliseconds? Event-based? Will it be, if we're talking about granularity space, about a specific cell, a specific region of the network, and so forth? And then there are other things which are a little bit more, need a little bit more time to explain, but I'm just going to refer to them, like data distillation, fusion, and aggregation, so that instead of sending fine-grained information, you can actually have aggregates or fused data. So that's an enabler for AI orchestration, and along with AI orchestration, both of them are the key enablers for native intelligence. Okay, let's try now to understand what we mean by AI orchestration with an example. Suppose that you have a virtual reality or an augmented reality service, and this service uses machine learning. The first thing that AI orchestration should be able to do is, on its own, to select the appropriate machine learning models to be used. Then that means that we go through a given knowledge base of models. And by the way, if you don't have all the models necessarily needed there, maybe that's the point that you have to also engage humans. But if you do have these models, then you don't engage humans at all. You take the models, you customize them, probably retrain them so that they match your needs. And here is where the story starts. So in this example, you got your access technology, you got your extreme at the edge, you got your extreme edge, which is the local equipment, and you got your local or inter-domain network with various nodes in between. Supposedly this user is playing a game with some other user like somewhere else in the network. So what do we mean by AI orchestration? Well, continuously, you need to decide where to place your machine learning models. One or more machine learning models, strategically placed in the network. Besides your given network, that may also include cloud resources, perhaps because you don't have enough resources within your network, or because there might be some proprietary models hosted in the cloud. And it may well mean that you host part of the intelligence or the whole intelligence at the access point, at the edge, or if you have very expensive equipment, even on your own equipment at the extreme edge. Okay, so that's the placement part. What about resource allocation? You decide to place your models, but you also need to assign the needed resources for inference. Besides the parts that you place your models, you might need to use resources in other parts of the network, like that could be, for instance, a database with history data for different versions of the models, and that needs to be placed in a different part of the network. So you see that orchestration involves more than one aspect. And by the way, there's no chronological order. It's not that you do first the placement, then you assign the resources. You do both at the same time. Then you need to decide on how you chain the models, because they are part of a distributed solution. And you have to link them to live monitoring and sensing from the network so that they can take decisions. And that has to be done efficiently within the requirements of the service and within the requirements of the quality of the machine learning itself. And besides monitoring for the service, you need to monitor AI itself. Is it behaving the way it's supposed to? If it's not behaving the way it's supposed to, then maybe you need to fall back to your selection of appropriate models, retrain them, and go through this continuous AI orchestration cycle. So this is what we mean by example with AI orchestration. We continuously keep doing all these steps together. It's a multi-objective optimization problem. It involves interdependent decisions. We have identified three important pillars. The first one is service management and orchestration, which involves all the functions and the protocols to deliver services efficiently, pretty much orchestrating resources for the services. This is not something new we had in the previous generations. And now we also identify two planes. A plane is not a set necessarily only of functions. It's a logical abstraction. It includes every component. This means also functions, but not only also functions. So that you acquire, process, and use information. This is where you do things like reasoning, explaining why, for instance, your machine learning models behave the way they do. Why did they take a decision to leave one user out and not serve that user? Maybe it was the right decision, maybe it was not. So the cognitive plane is about all the components, including functions, about cognitive cognitive actions. And then you've got the AI plane, which involves all of the machine learning models and AI models that continuously enhance, optimize, and automate your network. So these are the three pillars: SMO, the cognitive plane, and the AI plane. And how do they interact? Well, if you use AI models for cognitive plane purposes, then you have what we call AI cognition. So you use intelligence in order to acquire, process, and use information. If you use these cognitive plane models or components in general for orchestrating your service, then you have what we call cognitive SMO. And it's a process that takes place before SMO actions, during SMO actions, and even after that. It's a continuous thing. And if you use intelligent models to take decisions on how to orchestrate your service, then this is what we call intelligent SMO. So these are three, let's say, combinations that you never had in the past in previous generations. In the past, you only had SMO with or without AI. And if you would use AI, it would have been a bolt-on solution. And last but not least, you've got AI orchestration. You use cognitive components for acquiring and processing information so that AI can decide on how to, what are the necessary requirements for orchestrating itself. And once it decides what are the requirements for orchestrating itself, it delegates the SMO to go through the AI orchestration steps we've seen before. So they all work together. How much time do I have left?
Less than 5 minutes.
Less than 5 minutes. Okay, I'm going to try to respect this. So all of them together, they facilitate something which we call task-oriented networking. It's a new paradigm. I think I'm going to go through that, given the time we have. So in this example, suppose that you are a vertical service provider. You describe at high level with a task descriptor what you want. That, for instance, could be energy-efficient video streaming. At that level, it's not technical so far. It's at a very high level. Well, you use the cognitive components and AI models together so that you understand what that exactly means, and you compose a graph of all the necessary sub-services and functions needed in order to deliver this. Then, after you do this high-level graph composition, you need to convert that into concrete tasks with specifically optimized options each. And obviously, you use, again, the cognitive plane and AI plane to do this. Once you come back with this very concrete tasks, you feed this back to both the vertical service provider as a proposed contract, and to the one or more infrastructure networks which are going to be involved into delivering this. So on one case, you got a contract, on here, you got a plan. If this is accepted, then you can proceed with the next steps. But if at least one of them rejects it, you need to understand why it was rejected, go through again an optimization process and try to improve, understand better perhaps what's happening, understand why it was rejected, and try to come up with a better plan and contract. So obviously you use these two again. But if they accept it, then you go to each and every domain, infrastructure domain, and you pass this task. And this time, everything is translated with a very concrete and predefined descriptor to specific KPI targets, specific constraints, and so forth. So the intelligent orchestrator, the local one within each and every domain, takes these well-known tasks that knows how to deal with them and conducts service and management orchestration. Once you have this, which means that you have the specific containers you use, the virtual machines, the slices, monitoring apps, you pass them to the very edge or cloud infrastructure with all the necessary resources, and you have your service running. So we went through the high-level thing, we negotiated, we understood well what we wanted, we translated with each and every domain into specific concrete demands like containers, VMs, and so forth, and now we have our service running. But that's not the end of the story. We need to use the local SMO, the AI plane and cognitive plane components all together all the time, because you keep trying to optimize how you deliver the service. Okay, having that said, this is what we have in mind as a new paradigm, and this is what we're working on, called the task-oriented networking paradigm. I would like to quickly talk about monitoring, and hopefully we can return with more technical details in the Q&A. As we said earlier, monitoring is very important. The way that we envision monitoring from within the architecture is based on what we call microservices. A microservice is a lightweight piece of software that is very flexible. It can be combined with other microservices so that you can scale. And it makes it easier to extend and maintain your monitoring solution. We can start from a low level of these microservices or monitoring apps, as we like to call them, which are probes either at the hardware or at the software as parts of the architecture. And these probes, they give access, they abstract actually access to different pieces of software and hardware and provide access to raw information. And that also involves, by the way, AI monitoring probes for AI models themselves. Okay, then the second logical layer we have here, the MMS layer or the monitoring microservice layer, takes that raw monitoring and does things like data distilling, fusion, aggregation. We start to gradually combine, after some relevant SLA, raw data into more complex or composite data and statistics. Then we can pass things into a higher layer doing analytics. So higher level statistics, even predictions if you want. This is perhaps the point that you can start involving some machine learning and statistical models to make predictions and so forth. Key KPI measurements and predictive performance AI is one of the key things to have here. And at the layer that starts logically at the top, you get whatever you have available from your analytics and perhaps any of the layers below that, and you start combining it together, stitching it. That means that you can stitch together data and monitoring that comes from AI probes, some statistical analysis, or some machine learning models within the same domain, or by applying privacy and other policies across different domains. I don't have the time to show this, but we have two different ways of stitching things across different domains. The one is called vertical and the other horizontal, but perhaps it's something that we can come up during the Q&A. So trying to wrap up everything. Starting from the 4th generation, we had typical orchestration of resources. Then with the beginning of the 2010s, we had the kickoff of 5G research. This is the point that we tried to bolt on intelligence on an otherwise telecoms architecture. Then we decided that with the beginning of 5G research, having the human standing in the whole process is not optimal. So we try to fully automate as we go through the 6G era, the whole process without involving humans by having native intelligence. Native intelligence means that you have all what you see over here, full automation, multiple access technologies involving the edge and the extreme edge, public and private networks, the cloud. Monitoring is very important, and at the heart of everything lies orchestrating AI itself. So that's the story of convergence and integration of AI in 6G, but it's the story so far, it's not the end of it. What does the future bring? So we expect that by early 2030s, we will have the first deployments of 6G. That's just a guess, okay? Maybe not, but that's what we expect. By then, we hope that by exploiting native intelligence, we will be able to have a more user-centric telecoms architecture. And some questions that come into my mind, well, there are many questions, but some that come into my mind is whether or not the task-oriented paradigm that starts from high-level descriptions will prevail, and if we're going to use it. Whether or not 6G will pose the last telecoms generation, that's a question that I've actually heard once posed by Dimitra, and I find it very interesting because if you have a fully automated architecture and a very intelligent one, an agile one, why would it need to be updated? The reason why we update from one generation to the next is because we are lacking something. If the architecture itself is extendable and intelligent enough to understand new technologies, new concepts, maybe the sixth generation will be the last one, the ultimate one. And another nice question, which we like to discuss here in BDFI, will 6G networks become a commodity? Will the business model move from telecom networks making profit by providing you the infrastructure, or should the infrastructure become a commodity and then create business just running on top of it? Quickly saying, I think that this is where we're heading to, and there are some indications about this. Okay, I think now we can proceed with Q&A, but I would like to leave this slide here up until we start discussing.
Thank you very much. Xenofon, that sounded very exciting, and for people working actually with data and people that like big data, I think this was a really exciting topic that has opened many questions, I hope, for the floor. So any questions from people being present? Yes, Alex?
Yes, it was a question actually. You mentioned that it's going to be human-centric in terms of a service. So is it, I guess at the moment, we can have things like quality of service on networks, very basic level. So this is kind of more than that, isn't it? So you'd have a kind of, presumably a policy based on a type of usage. So you, say, for example, if someone's watching a video on their phone, might there be some kind of policy that the device has set that then the network tries to kind of meet that, depending on what obviously is available, kind of how it would kind of work?
So the question is whether that is going to be different in 6G.
Different to how the networks operate now, then I'm assuming it obviously is.
The way that networks operate right now is mostly based on quality of service, specific KPI targets. But at some point, I think that I should go to a specific slide that we visited.
So take it at the moment that'll be based on, say, network latency or speed, so basics as opposed to...
So during the presentation, if you remember, I went into this slide and I used content from a previous slide by Dimitra. in the future, you will have key value indicators, and they will go beyond just describing explicitly what should be the number of frames delivered to the user, what should be the delay. What if you as a user also want to enjoy a sustainable service? Would you be willing, for instance, to sacrifice your quality of service so that it's more sustainable? Maybe as a user you would, maybe not. So that's what's different in this case. You have a series of one or more KVIs, and the native intelligence has to decide on how to translate this to quality of service, to specific targets for quality of service. While these days what you do is just jump straight here. You have to explicitly give from the beginning, and not just for a specific user, but for the service itself, a set of KPIs. But in the future, if you want to make it human-centric, it has to come from the users themselves. And each and every user of the same service might have a different set of KVIs.
Yeah, I presume that'll be part of the standard and have some kind of API or some kind of mechanism for kind of exchanging information and sort of requesting the policy that you use.
Yeah, so there will be standards, there will always be standards describing, for instance, monitoring, the feedback that you get back in order to understand if you are violating or if you're complying with KPI targets. And perhaps we will also have standards about describing KVIs. To my opinion, it shouldn't be as an article saying that whoever comes and invents a new KVI can come up with it, or maybe it will, I don't know yet. That's actually going outside of the domain of my research, and becomes more of a cross-disciplines thing to discuss. A very interesting thing to do within BDFI.
So I did have one other question actually. It was regarding the diagram we had with the two effectively cell towers and the device moving from one to another.
Okay.
And was using sort of AI and ML. I take it at the moment if someone's say walking or in a car and the device switches between a cell, is that a decision that's made by the network operators automatically?
So
or?
currently, this is a decision that you have no control over. And what we did, so since you're asking about it, then I have to go through what we did in this case. It's part of the integration story, actually, because we started from trying to bolt on intelligence. Whatever I'm going to describe involves human effort, and 6G should be done by the network orchestrator itself, the AI orchestrator. So we are actually at this stage that we tried to integrate intelligence. What we did in this project called ZeroDing is that we worked on explicit models that do mobility predictions. We also take care of the local radio monitoring. We take radio monitoring from one cell and another, and we keep trying to predict what the received signal power and quality will be in the future. Then we pass this to a set of specific cell classifiers, as we say, classified to a probability of being handed over, because you have no control over it. Now, in the future, that solution should have been invented by the network itself. Not only that, but it should provide privileged access to our models, not to predict when a handover happens, but perhaps influence handover, decide when to happen. Now you can't do that.
It might be like a network provider or service provider has effectively like a map, say almost like coverage, so it knows if someone's going to an area.
Yes, but it has to be the same network provider. In the future, you might be creating a network on the fly involving parts of the infrastructure from different physical providers. That you can't do that seamlessly right now.
But that might be a form of intelligence that it could use to kind of predict.
Okay, and not to forget to give the end of the story, and then proactively place the service based on mobility prediction. While in the future, it should also be possible to impose the rules of how to migrate one user to another place.
Okay, thanks.
Other questions?
Thank you so much, Jennifer. I do apologize if I did not get some of the stuff that you were saying, but I'm just wondering in terms of this is really interesting what you said about, you know, the whole, I think the whole logic, the whole philosophy about what you're trying to do is basically to tailor something to the user. So the user defines what they want from the network, right? So But
The user or the service provider in the future.
Okay,
Not individual
okay.
users necessarily.
that was my question. So for example, I mean, we know that with the technology, we're becoming, dumber and dumber and more disconnected. Whatever they give me, I just use and don't question. And I suppose, what is the difference between then being user, what's the role of the user in this space? Will I be able to, for example, in the future, define that I'm really concerned about privacy and safety as values, key value indicators, and then, tailor whatever I get based on that? Or will this be something that is the decision taken somewhere else by someone else, human or AI? Does that make sense?
So it makes sense because
Yeah.
if you notice at some point, we had some slides saying that you come up with a plan trying to satisfy high-level requirements, which is passed to the infrastructure, but then the original requester, in that case the user, gets back some feedback. And that feedback involves a series of things, from how much they charge you, up to, it could be probability of guaranteeing that they're going to deliver what's asked for. And then it's up to you to decide whether you allow it or not. And if you want to dig into more details, if you are a little bit more expert, or if you have a local translator, if you want, of technical terms into more high-level ones, the network could explain to you that, okay, that means that we might, based on usual consumption of this service, we might need to spend a little bit more energy to cover this area of users. Would you be willing to accept this? So yes, long story short, there will be some feedback to the user, depending on how well they understand. They will be able to reject it or accept it. At the end of the day, if you want to get into these details as a user, you should be also able to either automatically say yes or educate yourself and understand what it means.
But you can move beyond the service providers.
Yeah.
Scenario and give eventually the whole power to the end user to set up either the KPI or KVI. And then if you have a very agile network, you can drive potentially a service from the end user. Now that comes with a lot of cost, with a lot of complexity. It assumes very disaggregated architectures. But there are things that people are considering, actually.
So it's part of this example that we used at some point about your own social network.
Mm-hmm.
If you remember this slide, we said that what if I want my own social network where I don't share content with anyone other than my device?
Yeah.
And then maybe I revisit this and change and say, okay, now I trust Angeliki as well. And I do trust her if she moves to Asia to keep hosting my content locally so that she can share it.
Yeah.
Without me having to share it.
That's what prompted my question. That's exactly what prompted
So
my question. So
that is the ultimate goal. Prioritize the user needs, even if they are super individualized, some very exotic. Like I might want to have global scale coverage, but at the same time, I want to make it fully sustainable. There might be some clashes here, but I can request it from the network.
thanks. I don't want to monopolize. I have so many questions, but I can talk to you later.
Ready?
So it's not a question, it's just completing the answer of Xenofon to your question, that maybe we can use some specific types of AI models that we can respect to the privacy of the users as well. So instead of exposing the real data, we can use AI models like federated learning, so not not exposing the real data of the user if it is very privacy driven.
And that thing about digital twins that we said, you could be first staging a digital twin to try to test if it works well. Then you keep monitoring the quality of the machine learning itself to see if it achieves the goals. Maybe at the end of the day, a user might ask something which is so exotic that it cannot fully be satisfied. This is why we know that you're going to be having clashes between your optimization targets. You can't keep everything, satisfied. So that's why things roll back to you to take the final decision as a user.
I think
Devika had a question.
Yeah, thanks, Xenofon. Just going back to the beginning where you talked about the role of the network administrator as, when a person occupied that role or continues to occupy that role. Can you talk a little bit more about what that job has been and what decisions are being automated?
So the traditional network administrator had access to a series of graphical user interfaces or scripts for the local system, that they would impose specific policies and rules. To give you one example, one policy could be that we do not conduct a handover from that cell to that one unless a threshold is being breached. Or that if a number of users starts to increase too much in the cell, we kick a number of users out or we offload them to another cell. That was based on some static policies and some rules, if you want. And the administrator was there in case something went, for instance, really wrong, and there was an alarm and they had to deal with it like an attack. Or for, along with other tools, trying to understand from statistics if things work well and then try to optimize the policies. So that was the role of the administration team, not just a single person, of course. Try to understand things, a whole team of people understanding, experimenting with new rules. There wasn't the concept of the digital twin, but I guess that they would have their own smaller scale simulation or emulation environments to try new policies. And then at the end of the day, they would try things on the network, and sometimes things would fail and you would have catastrophic events, okay? I'm not claiming that with AI we will avoid this. What I'm saying is that our vision is for AI being able to cope with these stringent requirements better, okay? I'm not saying that decisions will be optimized, but probably better, and within very low time constraints. If there is, for instance, a public incident, a PBDR event, and you need to set up a network on the fly, involving coverage in an area that you normally don't have enough coverage, and you need to send a nomadic node. A human administrator with static policies wouldn't probably do that well, because static policies are static, they don't adapt to the local environment. With AI, it could start training itself on the fly, or it could identify what's the nearest possible scenario that I'm aware of, and then deploy that AI to start taking decisions, and with online learning, keep learning from feedback from the network and try to improve itself and how it orchestrates the local resources. A human administrator, if they were super experts, they could do a good job, but probably wouldn't be enough.
Just so that I understand, could you give an example of a more like mundane routine decision rather than something like a crisis?
Well, human administrators wouldn't, they would have a routine, I guess. I haven't been an administrator myself to give you a very good example, perhaps, but I don't believe that every day they would go to work and keep changing and tuning things. These are very serious decisions, and that's why the services were very static. Now, don't forget that in the 6G world, even the services themselves are not static, they're exotic. So no matter how much experienced you are, you will never have access to enough knowledge and information as much as a machine learning world does to take these decisions. Like, it might decide to switch off completely one cell. And then you have to understand why it did it. Maybe it did it.
May I say something? In BT's building across the road, they are hosting their full network monitoring and administration. Maybe we can organize a field trip there.
Yeah.
Because we have organized one for Smart Eden Lab. So what they do, they actually monitor the health of the whole network, both fixed and mobile. So you see these big screens that they usually don't get you very close because they don't want you to see faces, right? But they have the administrators there. So not everything is actually a crisis. But the administrator, through the monitoring in the screen, they could make interventions on the network. So if performance somewhere is not SAP, they may be rebalancing traffic in the networks and traffic from another route, so they just increase performance and things like this. Quite a lot of these things right now are very manual, and if you go, you can see, and you say, oh, are these 5 people in front of there? They are actually controlling the whole BT network nationally. It's scary.
And they're following a protocol. I mean, I'm quite sure, if shouldn't be sharing this perhaps, but I was never an administrator, but I have seen how they administer things and at some point in my life. There is a certain protocol. They need to tell somebody else, and then another person might be actually responsible and have the authority to take some decision. Even if you understand that you're under attack, maybe it's not up to you to sort it out. So they need to follow a protocol that takes time.
Let's make a field trip
Yeah, I
there,
think
because
we-
just across the road, quite a lot of people from Smart Hidden Lab, they went. I don't know, Sandy, did you
No,
go?
I couldn't.
Uh,
But it will be great. if
Yeah.
We can have a.
We can request and go
Yeah,
to their operations center.
I think we got another question.
It's just maybe it's a bit of a cheeky question, Xenofon, but off the back of this conversation about network administrators, I'm just curious if you have any thoughts about what is lost by the removal of the network administrator in this process.
That's a very good question. One other thing that we don't want to lose is reasoning and understanding why things work the way they work, why some decisions were taken the way they were taken. And I'm not saying it because of sci-fi and AI attacking us back. It's because there might be decisions that at some point they may even implicitly cost lives. But you need to understand why that happened. Did it happen because your high-level policies were responsible, or because your data were not enough to train the necessary the models? That's actually a very good question. It's an open question, and I don't have an answer yet. It's and it extends beyond the integration into 6G networks. It's a more general thing, machine learning and AI.
So say you had a natural disaster and your cell coverage went down, you may want to manually intervene to say, I want to prioritize, say, voice calls rather than data or something like that.
And vice versa. Okay,
We could take this discussion out of
we
this
didn't
room.
talk about monitoring, which is my
Oversee.
favorite part, and some other things.
That's
We can do it another time.
What did you want to ask?
I want to know the dangers of
There's tea
monitoring.
and coffee outside, so
Okay.
I'm sure.
Do we have any question from our audience online?
Yeah, that's a good
No,
question.
No, okay,
we don't.
then
Yeah.
that's fine.
Just to wrap up that very interesting discussion we just had, I mean, I would just, in terms of a study of what network administrators as a kind of professional role in the software services industry, or whatever it is that could be an interesting interdisciplinary project to kind of really understand what it is people do who occupy these roles, and to what extent it's kind of, crisis-related situations, to what extent it's
As you
more-
said, that's interdisciplinary, so
Yeah.
It is.
instead of having one human doing this, let's just give the job to the AI. Things at the same time, and then they could possibly explain it back to you why they did it. It's too much for one person to comprehend, okay? That's what I believe.
Some people, for some.
For some people, yeah.
We don't have that many
That sounded
people
scary in the end.
That's why we use bulldozers. There are strong people, but we'd rather have more efficiency.
That analogy I like. Thank you so much.
Okay,
Let's
thank you so
thank
much.
you.